Hello everyone, I'm Siri K, studying at Sri Venkateswara College of Engineering, CSC branch, third sem. Now I'll be discussing about the analysis and design of algorithm. The topic is sequential search. Introduction to sequential search. Sequential search is a simple searching algorithm that scans through a list one item at a time. It is also known as linear search and is often used for small lists or unsorted data. The algorithm stops when it finds the desired element or reaches the end of the list. You can see about the mentioned example here. How sequential search works. To perform a sequential search, start at the beginning of the list and compare each element with the target value. The target value is 7 and the beginning of the list is 9. If the element matches the target, the search is unsuccessful and the index is returned. If the end of the list is reached without finding the target, the search is unsuccessful. Time complexity of sequential search. The time complexity of sequential search is O(n), where n is the number of elements in the list. In the worst case scenario, the algorithm may have to examine every element in the list. Sequential search is not efficient for large data sets or when the target element is near the end of the list. Time complexity. In time complexity, algorithm best case, average case, and worst case. This is linear search, binary search, ternary search, jump search, internal polation search. Space complexity of sequential search. The space complexity of sequential search is 0, 1 because it only requires a constant amount of extra space. The algorithm does not require additionally data structures or memory allocation. Sequential search is more efficient but may not be time efficient for large data sets. Complexity of sequential search. How many comparison operations are required for a sequential search of an n element container? In the worst case is n, in the best case is 1. In the average case, 1 plus 2 plus 3 plus to the plus n but divided by n is equal to n of n plus 1 by 2n is equal to n plus 1 divided by 2. In this case, we say the complexity of search is in the order of n, denoted as 0n. Can we improve this algorithm? Advantages of sequential search. Sequential search is easy to implement and understand. It is suitable for small lists or unsorted data. No reprocessing or extra memory is required for this algorithm. This is the advantages of sequential search. Next, the disadvantages of sequential search. Sequential search is not efficient for large data sets. As I said before in the introduction, it has a time complexity of O of n, which can be slow for large lists. The algorithm may have to scan through the entire list even if the target element is found early. Like it is the 9 is the first element and the 7 is the target element. Use cases for sequential search. Sequential search is commonly used in educational exercises and introductory programming courses. It can be used for searching in small databases or lists with a few elements in an array. Sequential search is a good starting point before exploring more advanced search algorithms. This is the use cases for sequential search. Tips for improving sequential search. If the list is sorted, consider using binary search for faster search times. Implement optimizations such as early termination if the target element is found. Consider the trade-offs between time complexity and ease of implementation when choosing each algorithm, search algorithms. You can see in this example. Example of sequential search. Let us consider an example where we have a list of numbers 5, 8, 3, 12, 6, and 9. We want to find the index of the element 12 using sequential search. Start from the beginning of the list and compare each element until finding 12 at index 3. Conclusion. Sequential search is a basic searching algorithm that scans through a list one item at a time. It is easy to implement and understand, but may not be efficient for large data sets. Consider the size of the data set and the requirements of the search when choosing the appropriate search algorithm. This is the conclusion of the selection sorting. Thank you.